do the full path. I just decided to use the full path of the bank accounts file. So let me try to run this again. See if that does it. And it seems to be working. So welcome to Programming 101. Today we're going to be using Visual Basic for applications to automate tasks in the office. Now, some people may argue, why are you teaching Visual Basic for applications? Well, because it's useful. It's useful for most folks working in the office. And number two, because it falls in the category what I call instructional programming languages. Basically, if a language has if operations, case statements, there is a flow, while loops and do while loops and for each and that kind of things, it's an instructional language and it shares a common foundation of instructions with other languages. For example, Python. Python has if statements, has while loops, has for loops. JavaScript, same thing. And a lot of people advocate for teaching JavaScript nowadays. C++, an old one, very useful still to our day, has the same kind of statements. So we're learning a foundation on programming and we are automating tasks in the office, which is going to be very helpful. So we have more time for learning. So what's the program? Over the course of a few videos, not sure exactly how many, we're going to cover programming Excel tasks with Visual Basic for application. We're going to cover an overview of scenarios found at the office that scream for automation. We're going to look into tech stacks for automation at the office. Visual Basic for applications is going to be probably 80 to 85% of the things you want to do automation wise, but you still need to leverage other resources. So we're going to look into what a tech stack is. So Visual Basic for applications combined with some PowerShell commands, maybe combined with some SQL, the structured query language or something like that. So we're going to delve into those as well to a point where we don't go into much detail. Going into much detail into structured query language or PowerShell or anything like that, that's going to be covered later at another series. We're going to look at task scheduling. Okay, so I need to handle an Excel file and we need to send an email. We need to drop that into a folder. How can that be automated to be scheduled to happen at some time? Automating emails. Well, you can also programmatically send emails. I had one occasion where they were asking me to send an email every single hour, Monday to Friday. I had to program that task. It was just crazy to do that every hour. And they were expecting me to be very manual about it. So I had to program that. Picking or dropping a file to a shared folder, that's a common scenario. Picking or dropping files to an FTP. As mentioned, using a little SQL querying. And finally, cheat sheets and checklists to automate tasks. A little more theory on automation at the office. This is going to be covered in a series of videos. Today, we're focusing just on Excel tasks with Visual Basic for applications. Okay, again, why starting to program with Visual Basic for applications? I'm going to go into more details. Visual Basic for applications is compliant with instructional programming. I think I mentioned that. Has while, for, if, function, routine programming, can query databases. Because number two, it's simple enough to start, yet robust. You can do a lot of things with Visual Basic for applications, at least in the domain of Excel or Microsoft Office. Number three, because we want to start programming from a highly visible and tangible standpoint, when we see the results of our programming in the Excel file, in the Excel workbook, it's going to really, give us a lot of clarity on what programming is and how it works and all of that. Maybe you already have some experience. Welcome. Maybe you have no experience. That's where we want to start. Number four, because you'll save time. The long hours of data manipulation have their days numbered. And because the world will be a better place with automation. So we're going to program starting from a scenario, payroll. We're going to have a file that we're going to pretend that we get this file every couple of weeks, every month, and that we need to program payroll. We need to process this file and convert it to a product that we can send to the bank. So that means that we're going to have a scenario where we have a file, needs transformation so that it can be uploaded to the bank, needs to become a CSV file, etc. Okay, so here we are. This is our main Excel sheet. Remember that this is a hypothetical example, although very realistic, where we're supposed to develop the payroll information, send it to the bank, prepare the file for the bank. we have to do a lot of data transformation. So there is a main Excel file with employee information with a lot of data that's probably not necessary for payroll. Like you don't care about the gender, ethnicity, maybe even the age, the job title, but you have important information like the salary. So part of the work is to curate this file before you transform that into CSV. And normally, a very realistic scenario is that you have additional files where you need to draw data from. For example, the routing number and account number. We have tax brackets information because we need to tell how much we're going to deduct from any given person. So in our example, the goal is we have to separate first and last name, disregard middle names, remove non-US employees, remove term employees because this has many different countries just doing the US payroll. We want to calculate monthly pay bonus, calculate the tax bracket, set the amount to retain and the net payment, get the routing and account numbers from secondary file, remove unnecessary columns, convert to CSV, and some additional tasks that are not exactly Excel related is to send the file to the bank through FTP and then send an email to management confirming the work is done. This is a very typical scenario found in most offices. So what we need to program is to go from this file, which we get from some source every couple of weeks, every month, get the bank information, routing number, account number, separate the first name, last name, get rid of columns, and compute what the actual monthly subtotal is, considering that there is a bonus there. So we're going to start a macro. What is a macro? A macro is like a routine where actually you can record some of the items, some of the things that you want to do, and you can use that. It gets recorded as code. How come it can be recorded as code, whatever action I take? Well, because each one of the actions that I take in an Excel spreadsheet, there's only a fixed number of things that I can do on an Excel spreadsheet. So that's how come the actions that I take can actually be recorded. For example, selecting a column, that's one particular action. So there's a code for that, an API for that, an application programming interface. I can select a row or I can select a range. That would be recorded as code because the selection of a range, the selection of a column, the selection of a row, the deletion of a row, the deletion of a column, inserting a column, those are items from a list of things that you can do in Excel. You cannot do anything out of those boundaries. So since there is a boundary on the amount of different things you can do in Excel, there is an API for each one of those. What we're going to do to get started is we're going to start recording a macro. Here on View, Macros, you go here and you say record a macro. You just click OK. What Excel is doing now at this moment, you see there's a button now that says stop recording, is that it is recording the actions that I take. So one of the actions that I needed to take here was get rid of columns that are basically useless. So we could start with just that. We had separate first and last name, remove unnecessary columns. So let's record that action because we're always going to have a job title under column C and department under column D and business unit under column E and all of that. I can safely just select all of this, age, hire date included from column C to I, right click and delete. I do need the country because I need to filter by employees from United States, not from China, not from Brazil. City, I don't need that. I can click on the column and say delete. I need the exit date because I need to get rid of those which are terms, but I also need another column next to the full name where I'm going to put the last name. I need first name and last name separated. So I'm going to insert another one because we need the routing number and we need the account number there. That's what we need to do. Routing number and account number. So in total I need 3 columns here empty because I'm going to put values there. I think we have enough material for the macro. I'm just going to do a control arrow key down because I want to record when you go to the limit. If you do control arrow key and you are in a value and you have a list of values, it will take you straight to the last value. And that's also a recorded action. So I'm going to now stop recording. And now I'm going to say view macros. And we have macro number 3. I'm not going to run it. I'm actually going to go to edit. And here's where I selected from column C to the I. And then using the API, application programming interface, again, what this is saying is delete and shift to the left. and then select column F and delete that as well, and select column C, and that's pretty much what we did. So what would happen, let's say I undo all of these actions. I just go and hit Control Z there, and I go to the original setting. Here we are, this was the original setting. What's going to happen if I go to macros, view macros, and I say just run this? Huh, it just performed the actions that were recorded. So one of the first steps, separating the first name from the last name. And as we know, most of the names here have a space in between first name and last name, but some of them have a middle initial. For example, Penelope K. Jordan, so you have two spaces, and that can be a little confusing. So we're going to start with creating that formula in code. For that, we just go back to our macros, view macros, edit, and we have the editor window. Like we stand probably to talking about what this sub is and what other kind of scope we're going to create. So scope is any declaration of a routine or function and its end. Whatever space there is in between, that's the scope for which you are programming. Macro 3, we're going to rename it to something better. But macro number 3 has these pieces of code. It ends at this point. And you can continue to do line breaks and continue to further coding this, but this is the scope. Whenever you call macro 3, whatever is inside this sub declaration and end sub statement is what is executed. And also within any scope, the starting point is the uppermost line to the lowest line. So you always go from line break to line break, executing each one of the commands. A reminder, this is all part of Excel's Visual Basic for Applications API, so columns.select, this is specific to the application programming interface, selection.delete, and all of that. What are these apostrophes? Apostrophes are comments. Comments actually ensure that the code is not executed. So here, for example, this is no longer going to be executed. So whatever the code execution reaches this line, it's just going to continue with the next line. I could just comment this, and so this would be executed, then this, then this, then this, then this wouldn't, and then this, and this, and this, and this. That's how you comment code in Visual Basic for Applications. Now, you could also, if this was still a valid command, you can also put the apostrophe after some code, and the rest of the code is going to be invalidated, and you're just going to execute this part. Again, we would have to ask the question if this is a valid statement, but you can do that. You can put an extra comment. Comments are very useful, but we're going to go into more detail later. So if this is the scope of macro 3, and macro 3 deletes some columns and inserts some columns, what about separating the first name from the last name? Well, a sub is a routine, whereas a function, it's a declare scope which generates a value, returns a value. So this one, subs, they only perform actions, and functions return a value. So we're gonna declare a function called get first name. Okay, that's it. We got a scope, right? And we have all this space to do the code. Okay, if I'm gonna get the first name out of something, you may want to pass it as a parameter. It could be in a stable place, but usually you just want to say, hey, for this value, give me the first name. So we're gonna go with something called an argument. An argument is just but a piece of memory which contains the value that is being passed to the function. A little more on that later. So how do I get value out of get first name? So on get first name, you will have to put the name of the function, get first name equal to, and whatever the return value is. So that's how you declare that you're returning the value. You put the name of the function and you make it equal to whatever value you want to return. Now, just to give you an example, let's say that we're just going to return hello world. Let's just see what this does. So if I go over here and I say get first name and I select the value from cell V2, that's the value that we're gonna get as a full name. So I hit enter and I get the hello world, because what I said is get first name equals to hello world. Well, I don't want that. I want just the first name. Okay, I'm just gonna put the full name here. See what we get? Get the same name, right? Okay, let's further this. Visual Basic for Application, again, has a vast API with several functions that are there by default and are native to the language, and you can use those, among them some string functions. There is a function called left, which gives you back a specific number of characters starting from the left of a character string, in this case the full name. And you say the arguments you need to give to the left function, API function, is string value and the number of characters. So I can return the left, the result of left for the full name, and let's give it 5 characters, see what happens. Okay, so I'm going to reprocess this and see what we get. We get 5 characters from the beginning. Not bad, except for Robert, Everly, Camila, so it's close. This function is getting us closer. Now, there is another function which returns what is the index number of the first appearance of a character, and it's called instr. So if in str I say, hey, for the full name, tell me where the first space occurs. It's going to return a number, which is the index number. This is 0 based. The first character is in space number 0, where we get a space. Okay, let's do this again. And it's telling, hey, Emily Davids, space number 6. Again, 0, 1, 2, 3, 4, 5, 6. Well, I thought it was 0 based. Sorry about that. Okay, number 6. Fine, it's not 0 based. So we're going to nest the instr function in this left. So I'm going to say from left full name, give me so many characters from the left up to the character number where a space occurs. So basically this, which looks more simple, I nested this formula, this Excel Visual Basic for Applications API function, and what we get is, voila, we get the numbers, we get the first names. Very good. But there's probably something wrong here, and I'm going to show you. Let me tell you what my suspicion is. So I'm going to paste this one as a value, Robert. What happens with Robert? He still has a space there, so that's not good. We want to make sure that we get this right. And this is a pattern. Basically, it's we need to reduce by 1 the get first name function. So what you do is that in str, on top of this being a nested function, we're going to do a -1. True this, that after the comma, it's just whatever is arithmetically or numerically sound. So I get a number -1. This is a sound arithmetic operation. You can think of it like, first we're going to resolve all of this before it gets passed on to the function. So you have a function, you want to nest another function, and you have commas which separate the parameters. So first I put the full name, no problem there, but this one is a little tricky. But you can think of it like all of this needs to be resolved and then it gets passed on. That's how it works. I can even remove that parenthesis, I don't need it. You can use as many parentheses as you like, but I just need the instr function -1. And what I'm going to get now is perfect functions here. I'm going to paste Robert as values, and there's no trailing space there. Okay, so that does it for the first name. Now I need the last name. So I created a function. See, you can create functions in Excel, like you have very complicated functions which don't exist by default, and there are complicated formulas. You can create a macro that where there's a personalized function, user-defined function, and just use it like it was any other Excel function. But this function has the added value that I can call it from the macro 3, or I can call it from any other function as long as it's declared. So we're not just going to use it here. We're going to use it within the macro 3 scope. But we'll get there. So first things first, let's make the other one function we want, which is get the last name. And get last name is probably a little more complicated because the first name is guaranteed to be the first portion of the string, and the first space is the one that definitely represents all of the time the point where the first name ends. But for the last name, we have people with middle initials. So it's a little tricky, like instr returns the first occurrence of the space or whatever character I'm looking for. It doesn't return the second one. So there is yet another API function called str reverse, string reverse. So what I'm going to do is create another function, get last name. I'm going to pass the full name again. And in this case, there's a single line of code, and probably we're going to do a single line of code. So get last name is going to be equal to str reverse. I'm not done yet. There it is. So let me try it. Get last name from full name. Okay, so I'm getting the strings in reverse order. So instead of Emily Davis, I get Sivat Elaim. This makes things a lot easier because now it is guaranteed that the first occurrence of a space is the one after the last name. So what we're going to do here is I'm going to say from the left, give me the number of the first occurrence of a space in here. I'm going to use in str again, but I cannot use it with just the full name because the full name is the right order. I'm saying from the reverse order. Okay, so reverse order, again, we're going to go from the last character up to the first occurrence from the left up to the first occurrence of a space, right? And so we're going to get in str. Let's see what happens. Okay, it got reduced, but guess what? We probably have again the problem with the trailing space. So if I do this, I need to adjust it and say do a -1. Okay, simple enough. -1. No more trailing spaces. But then this is the reverse last name, right? So what do we do? If we reverse first, we reverse again. And we see a lot of nesting here. And it's okay. You can nest functions as much as you need. You don't need to worry about it. So what we're seeing here is that here the innermost is the string reverse within the in str, whereas the in str as well as the left is in a string, yet another string reverse. As long as your logic is sound, you're not going to have any problems. So let me just put away these spaces and let's see what we get. Yeah, we got Davis, Dean, Sanders, Jordan, and if I paste these as values, I'm not getting any trailing spaces. So we got our functions here. As we saw in the previous examples, we define the scopes, and that's very important because every time you work with an instructional programming language, you're going to see yourself in a situation where there is a scope of code where code goes from the topmost line to the lowermost line. And you can have methods or routines, which are events and actions which ultimately don't return anything, or you can have functions where in the end a value will be returned to whoever calls the function. Depending on the programming language you use, there may be a very visible difference in between a function or a method. In languages such as C, C++, C Sharp, Java, you don't see much of a distinction. Basically, you see a method which returns void, which basically means doesn't return anything, or you see a method which returns data type. But in most other languages, here it's not the case in Visual Basic for applications, there is a main flow. So there will be a main scope where the code actually begins, where the program begins, and you have the first line of code, second, third, fourth, and then you may use functions during the execution, or you may call some methods and perform some actions as the program evolves, as the program runs and fulfills its purpose. Now, it would be good to show a few useful Visual Basic for Applications API functions. These are, again, native functions which you can call all of the time. There's no special need to do anything else but just call them. And you can separate them in categories. For example, string related functions. Some of these we saw in the last example. We saw str reverse, which reverses the order of the characters in a string. In str, which returns the first occurrence of a character within a string. The len function returns the length in characters of a string. You can think of a few scenarios for using that. Left or right. We use left, there's also right. In right, what you do is basically, again, you put the string, you put the number of characters you want starting from the right instead of from the left. There's a function basically called string, which stuffs, returns a string with a character repeated as many times as you want. So you say, give me 10 times the character R, and you get 10 R's altogether. Lowercase, uppercase, basically returns your string in all uppercases or all lower cases. Other useful functions, date functions, very good. The first two are not actual functions. You could say that they are like system variables where you get the current date in the system. So you call date and you get the current date as per your computer, your operating system. Now gives you back the date with time and of course minutes, seconds. So it's a more complete, more complex date value. There is a wonderful function called date add, which you give it a date interval and it adds that amount of intervals to a specific date. So let's say today is February 10. Okay, so in date add on the date interval part, you define days and you say 10 to February the 10th. So you add 10 days to February the 10th, you get February the 20th. But you could also add weeks. You can add a month. And it's especially, it's noteworthy that when you add a month, basically it doesn't regard months that have 31 days, 30 days, 28 days, or Februaries which have 29 days and things like that. So for example, if you were to say date add 1 month from February 15, it will return March 15. But if you did the same on August 15, you would get September 15 in return. So it depends on the calendar month that goes in between, and you'll get exactly 1 month after, regardless of the amount of days in the month. So that's kind of noteworthy. Then we have date diff, where you give an interval. You say months, difference in months, the difference in days, the difference in years between a first date and a second date. Then you can get the year value out of a date, the month value out of a date. So let's say today is March 31st, 2024. You set year and you get 2024. You put the month, you get a 3. You get the date, you get 31. Hour, depends on what time it is. You can even get minutes. And another group of very useful functions would be some mathematics functions where you could have, for example, ABS, absolute. Basically, you get a number. If it's negative, it turns it to positive. It's basically the absolute value. You also have the three most basic trigonometric functions, sine, cosine, tangent. Whatever value you put in there, it's interpreted as being in radians. So make sure, be careful with those degrees. Turn them to radians before you actually use any of these functions. Then there's a random function where you get a totally random value ranging from 0 to 1. So you get a large mantissa, 0 point and I don't know, 10 numbers, 20 numbers or so. And then you have SQR, which goes for the square root of a number. However, if you know a little theory, a square root is nothing but a power. So for example, the square root, which is the root of 2, is same as the power to 1/2. So on our next chart, we have actual operator, addition, subtraction, multiplication, division of any given number, and then integer division. So the slash, the forward slash that we always use, we typically use it to divide in Excel, basically gives you back a division, and if there are any decimals that need to be shown as a result of the division, it brings you up the decimals. The backslash, actually it returns the result of an integer division. So for example, you said you divide 5 by 2 with an integer division. The result is 2, it's not 2.5. But then there is the mod operator. The mod operator will return the remainder of an integer division. So if you have 5 mod 2, because you have a 1 remaining, the result of the model is 1. That can be very useful in some scenarios. Then you have the little kind of triangle, which is the power. That's actually to do powers. And again, you can do square roots, you can do cubed roots, fourth roots, and all of that if you just raise to the power of 1/2 to 1/3, 1/4, and so on. Then we have the concatenation operation, operator, which is an ampersand. You just have a couple of strings, and you use the ampersand, and you come up with one single string joined as you use the ampersand there. You have a comparison operators, and these are useful. Basically, what you get is a true or false in each one of the cases. So you put a couple of numbers and you put greater than, and it will be true or false, right? So you have 8 greater than 4. So what you get is true. This is actually true. And you have less than. So you've put 8 less than 4, then that's going to return a false. So that's not going to be a valid condition. This is going to be very important in our next point. So you have greater, greater or equal, less, less or equal, unequal or equal. And then you can join different operations using logical statements where you actually force things to continue to be true with an AND operator, or when you're more flexible and feel like only one of two statements or one of three statements or one of four statements needs to be true, then you join them with ORs. You can negate something. You can say, well, not, and you put a parenthesis, not 8 less than 4. So 8 less than 4 returns in a false, but it's embedded in a not. So you actually get a true. Sometimes it works. It's good to use that. And you have XOR also. XOR, not many people use this one, but basically you have a couple of statements and you join them by the XOR. XOR results true if only one of both statements is true. The other one has to be false. So I don't care if the one to the right is true or the one to the left is true. As long as only one of them is true, then it's true. If they're both true, it's false, and if they're both false, it's false. And then you have the assignment operator. Basically, whatever variable you have, you make that statement to equal, and then you put the value there. And there's a line continuation operator. So if you have a long line of code in Visual Basic and you want to continue on the next line, you can just put a space at the end, underscore, a line break, and on the next line you continue your statement. So all that has been stated is going to make a lot more sense when we see this flow control element, the if statement, because that's what we're going to use next in our program, in our macro. So what you do here is flow control. Sometimes you don't want some pieces of code or some code blocks or scopes to be executed, and sometimes you do. So you have if conditions. So you come from a situation where you have many lines of code and then you reach an if. And if calls for checking a situation for a comparison. So for example, you have a couple of variables or a couple of values there, and you want to make sure that one value is greater than the other. Then you go ahead and execute some code if that is what you want. So for example, you check if a condition is met, then you do some code and you end with an if. The example in the middle of the other two, we have a situation where if a condition is true, then you want to execute some code. Else, so if the condition is not met, everything else just continue with the next part of code and then you end the if statement. Then you have another set of conditions. You can do if some condition, then execute some code. Else if another condition, then there's another code block. Then else if some other condition, then there's another code. And then else if nothing else is possible, then you can also do a last block of code that you want to do. So what cases could be suitable for such an if statement to control the flow of what gets executed or not? Well, we saw that there is a tax bracket example, and even though it's an oversimplified tax bracket example, because tax brackets are more complicated than what we're doing here, you can think of if income in between this amount and that amount, then code. Else if income between this amount, that amount, or income greater or equal than the lower limit, less than the upper limit, then code, and so on, and you make assignments and all of that. So let's go to that example. Okay, so back to the Excel file. We still have these values. We're going to leave them here for now. No rush to remove them, but we need to start working on a function that will return the tax bracket you're going to be in, and for that you just want to be able to post any number into that function. So we're creating another function here basically to return the tax bracket, and let me use this special occasion to tell me how mad I am at tax brackets, because they're always stated wrong. How come? Well, The tax statements basically set a lower boundary and an upper boundary for each one of the brackets. But as you can see, if the upper limit is $11,000 and then the lower limit one is 11,001, then you have 99 cents that are not taxable, are not in the bracket. So that is not really arithmetically sound. So we're going to make an arithmetically sound statement here using the if statement to control the flow and determine what the tax bracket should be. We're going to state things right. So we're going to get function get tax bracket. We're going to go to annual income. That's the end of the function. And next thing we're going to do is if you want to create a value that you're going to operate with, you're going to assign a number, a value, you're going to assign it a string. What you want to do is to use the deem statement. So I'm going to deem here, I'm just going to say a rate or tax rate. Okay. And I'm not going to assign anything to the tax rate, or I could assign a 0 if I wanted, but I might as well not assign anything. It really doesn't matter. And here's where the annual income is going to come and play a role, because I'm going to do an if statement. So if annual income is less than 11,001, then we want the tax rate to be equal to 0.1, which is 10%. Okay. Else, if annual income, actually it's important that you're just going to fall into one of these. You got an else if, so I can just do less than 44,726 up to the last decimal. This is going to work. We're not going to see any statement out of place or something unassigned. Tax rate equals 0.12. Else if annual income less than 95,376, then tax rate should be equal to 0.22. Notice that I know that this is not how taxing works and that there are other tax brackets depending on whether you're the head of a household and things like that, and there are deductions. So here we're just trying to do a sort of realistic example, right? And tell where we could apply an if flow control statement. So then else if annual income, so as long as it's less than $182,101, boy, I wish I could make that money. Tax rate is going to be, even if I was going to get really badly taxed, 0.24. Else, if annual income is less than 231,251, then the tax rate is going to be equal to 0.32. Else, if annual income is less than 578,126,578,000, then else if tax rate is going to be equal 0.35, excuse me. Else, if it's not less than any one of those amounts, then we're going to get something extraordinarily high, which is tax rate equals to 0.37. Okay, and that's the end of the if statement. What we're going to do in the end to get the tax bracket is we're going to put here, we're going to give back the tax rate. Now, somebody may argue, is it less than 11,001? Maybe we need a bigger base than this. Maybe we need if annual income less than 0, then tax rate equals 0. And else if, it's probably better, more accurate, because someone could be in total debt. That'll be really bad, but it's also possible. Now let's see how get tax bracket works. This is not the exact formulation because we need to then put the bonus on top of that, but let's say equal to get tax bracket. Here we get a 24, 24, 22. Everything seems well. Okay, so that's how we're going to get the tax bracket information. You know something? After we did this, I realized that the tax brackets change or the amounts change depending on the year. Every year they adjust for inflation and things like that, and they set new amounts and so on. So this is not always going to be true, and you want your tax bracket function to be accurate to the year. So let's pretend for a moment we could make a statement like, depending on the year, use this. If it's 2023 or later, then use this. If it's earlier than 2022, then use something else. That's when we want to see a function that probably has an additional argument. So you could go with a year, but year might be a reserved keyword. So I'm just going to use YR. And I can even embed or nest this if block into yet another one. So if year, let's say greater or equal than 2022, something like that, then you're going to get this. Else if, and then you can get another tax bracket or something like that. You could get year less than 2022 and year greater than 2015. Let's say the last one was in 2015. Then is else, another one, and if. So you could have another one of these trees, adjust the values for the year, and so when you use the year, you're going to be able to do much richer operations. I'm going to leave the same tax brackets. I'm not going to go as far back, but this is, for example, another case where you could have embedded nested if statements, and you could be using a second parameter, third parameter, fourth parameter. So it's important to enrich the functions to that point where we use multiple parameters. So this is fictitious work, of course, and there's probably way more brackets in history, but I'm just going to use the same numbers for the sake of the example. Thank you. So we're back with the next items in the flow control elements. Again, a reminder, we call these control flow elements because typically in a scope we execute the lines of codes from top to bottom, each one, but then if you meet one of these elements, the flow of the execution can be diverted. It can change, it can go back and go forward and so on. So we're now reaching the loops. Loops are exactly that. You have a code block and then you execute this as many times as a condition is met. And we have four different kinds of Visual Basic for applications. We have the for counter, which is by far the safest because you set a variable, let's say an integer variable, equals to an origin value, and it will go in increments of 1 every time it reaches the next counter. So you say for counter equals 1 to 100, you execute the code block, you say next counter, and automatically this number 1 increases to 2, and on the next run increases to 3, 4, 5, 6 until you reach 100, and inevitably the loop ends. And then we have the for each item in collection, then a next item. So for that kind of loop, what we have is that you can have collections of objects in Excel and Visual Basic for applications. For example, in Excel you have worksheets. So if in the workbook you have 10 worksheets, you can say for each worksheet in the workbook.worksheets. And when you reach the next item, you move up to the next one in the collection. They're not necessarily numbered. Well, they are like 0, 1, 2, 3, 4, 5, but you don't mind about the numbering system. You treat them as an object. The sheet is going to exist there, and you're actually moving into the scope of using that particular item. You can use the item in the collection. If there are properties that you can use, then you can insert those in your code. You're going to see later examples on that. Then we have the two kind of dangerous ones, do while condition and do until condition. And one should be especially careful using while loops, for they could cycle and ruin program execution. They can run in an endless cycle. You would have to interrupt the program. This can sometimes force your computer quite a bit. So basically you have a condition and you have a code block. And when you end the code block, you loop back to the condition. If the condition remains true, you go back to the code block, you execute everything, you loop back. The condition remains true, you go back to the code block until it ends, then you loop, and so on. So needless to say, you got to make sure that the condition at one point is no longer going to be true. So at the point when the condition is no longer true, then you're going to break out of the loop. So watch that condition. You have do until condition. So you have that the condition is from the beginning not being met. It's actually resulting in a false. So you execute the block and then check again the condition. Is it still false? Then you gotta go back. You gotta run the code as many times until the condition is met. It has to continue to be false until it's met. Whereas in while the condition has to be true for it to continue, do until the condition has to be right for the loop to go back and loop again, go back and go back and go back. That's how it works. So we're gonna go and we're gonna use pretty much the for counter equals to origin to limit. The for next counter in our next example, you'll see. So probably the first thing we want to do is to get rid of the rows that shouldn't be part of the report. We should remove employees from China, Brazil region, people who are termed that are no longer in the company, whether they're in the US or not. So because deletions actually alter the rows that you have here, see, and this is what I mean. This alter the rows, and let me control C here. We probably want to start from bottom to top whenever we want to do the deletion of personal. So one way to do it is to understand that, for example, you always have employee IDs, so you can do always the down arrow key to reach the bottom and tell what is the last row. And from then on, just move upwards and check for China, for Brazil, for terms. And if such a thing happens, delete the row, then move up, delete and move up, delete and move up. So this is how we're going to do it. We're going to we're going to create another sub. So instead of calling it macro or something like that, we're going to create a sub that's going to be called remove unwanted rows. That's it. We created the scope. So remember that I did this in the beginning, selection dot and Excel down range a1 dot select. Actually, I'm gonna take this, I'm gonna put it over here. So range a1 dot select selection dot and Excel down dot select. Let me show you. We're gonna insert some toggles. When we do this and we run our sub, what happens is that it breaks on each one of the lines of code and it execute in a snap. It just goes really slowly one by one. So what we're going to do here is to test it. We're going to put the cursor inside the sub and now we're going to click the play button. So the first one is range A1 select. So it's going to go to the first cell. There it is. And then selection.and Excel down dot select. So we hit it and it went down to the bottom. So what needs to happen next? I probably want the number. I know that I just selected the very last one because it's safe to do so from the first column, because on the first column you have the employee numbers. So I'm in the last one. I didn't explicitly hard coded say go to row 1001 because on the next report that may not be true. So this is the safest way to do it. I know that the employee IDs are always going to be populated. I know that if I execute this code snippet, I'm always going to go to the last one. So from here, after I want to go do until active cell is the current cell I'm in. Dot row is a property. Do until active cell dot row equals 1. Then I'm going to loop. So unless I reach this point, I'm going to loop and go back and go back and go back. I know that I'm in the last row over here because that's the inevitable consequence of these two commands. What I'm going to do now is I'm going to check if column H, the value is either China or Brazil, or there is a date in column I, and that's going to tell if I should remove that. I'm going to delete these values just so they don't distract us. Those are just test values. So we know we're here, and what we're going to do is our piece of code should be column H. So what I'm going to do is if range, and I'm going to use the active cell dot row, but I'm also going to use age column ampersand. So this means if range H, sorry, not the column, but H and the row. So if H1001 dot value different from United States, then active cell dot row dot select. Actually, I need a range, or I need a row indexed. I can use active cell dot rows ampersand column and ampersand active cell again dot row dot select. So I'm trying to do pretty much what we did here. So we have columns ci select. So I'm trying to select the row if it doesn't say US. Then I'm not going to delete yet. I'm going to pretend that I'm going up, right? So in the end, whether or not this happens, I want to go to active cell dot offset, and for rows I want to do a -1 and 0 and then go select. What does this mean? From my active cell, go -1 in the row, so you go up, and no offset, so you remain here, dot select. So let's see how this works. Maybe I need to go back. So it seems to be selecting well. We can see that it goes up, and whenever it's not the United States, then it selects the row. So we probably need to add another condition there, right? So it is selecting. Now I'm going to do an else if. I'm going to do basically almost the same range, but I'm going to use column I and active cell.row.value different from nothing. Why? Because it typically is empty, so it's either empty or it's populated. I'm going to go same operation, select, and we're always going to select the offset. So let's illustrate this again. I'm going to stop this. Our first statement, range 1, selection, index, etc. Range A1 select, selection.end, and we're in the loop. Do until active cell.row equals 1. This range, this is United States and it's not populated, so it immediately went to the offset because none of these conditions were met. So here we're going up, China selected, China selected, and in addition we have the date. Brazil selected, China selected, China selected, China, and the next one got selected because I-984 is populated. So we continue to offset. So we're going up. It seems to be testing well, so it's time to do some deletions, okay? We can probably use one single statement. We can increase this. Instead of doing two statements, we can just do an or. So we're going to do or. Yeah, come on. Sure, whatever. That's the only one thing I hate about Visual Basic for applications. It's very noisy whenever it says some condition. It pops up. It helps you not to fail, but at the same time it's a little annoying. So rows, active cell.row and column, what we're going to do here is selection.delete shift excel up probably. So I'm going to do selection.delete shift I don't need to memorize this. Remember that we manually recorded. Shift Excel tool up, probably. Let's try it. Let's just try it. It will fail if something's wrong, but bang, gone, gone, going up. Brazil, China, China, United States. Actually remove the term employee from the United States, and it's still looping and looping and looping until active cell.row equals 1. Until that doesn't happen, it's going to continue to loop. So let's go. Let's go. Let's keep testing. I want to see yet another United States employee whose term date is selected. Alice Roberts. There she goes. Okay, this is working perfect. Now, we're going to let this run all by itself, and it's going to run in an instant. You'll see. We're going to put our cursor inside our sub, remove unwanted rows, and see. Well, is that amazing or what? Look at this. Just look at this. Perfectly. All rows we didn't want are gone, and now we can run the same kind of loop for the other guys. We can create another loop statement so we can fix the full names and stuff. Actually, let's go right into that. All right, before we move on to the next point, I just wanted to see how we've progressed in creating this macro and recording this. So I wanted to just get the list fresh and run everything in the code. So we have macro number 3 here. We have a basic selection of columns. We're going to execute this one by one. But the next thing we want to happen is that we want to run the remove unwanted rows sub or routine. Now, if we're going to run macro 3, then macro 3 needs to call remove unwanted rows. So how do you do that in Visual Basic for applications? Well, to call a routine, you use the keyword call and you put the name of the routine, remove unwanted rows. You put it right there, and that's all you need to do. So automatically when it calls this, it's going to divert the flow into this sub, and then it's going to start executing these commands. So let's just see our work in action so far, then continue with the next steps. So here is the list. Here is sub macro 3, and we start. It breaks in each one of the commands because we use the toggle breakpoints, and it selects column F. Now it deletes. It selects column C, and now it inserts, keeps that selected, inserts again, and then it inserts on D, so we get 3 columns, and now it calls remove unwanted rows. And remove unwanted rows goes to range A1 and then down to the bottom, and then it goes into this loop statements where it checks for countries other than the United States and the term dates if the employee is in the United States. So here we go, selecting China, Brazil. It's going perfect. So what I'm going to do here is just remove all of this and let it run till the end. All right, so the next part of the code that we need to program goes after calling the remove unwanted rows, because when you're done calling this, the flow is going to divert to the next point in macro 3. By the way, maybe we should call this something different now. Instead of macro 3, what do you think could be a good name? Probably, I don't know, format payroll data, something like that. That's probably more descriptive. Let me remove these items here, and what we want to do is we probably want to create another sub that's go to the A1 or something like that and get the last name and the first name and put them into column B and C. So columns B and C, we're going to change those. Let's see, probably best would be to go to C1 or even B1, B2. So I'm going to create another sub split full names. It's probably a good name. So we're going to go to the range. We could even go to A2. Really doesn't matter. A1, that's fine. A1. dot select, and then we want to do the same trick as before. We want to selection dot and Excel down dot select. We want to go to the last one, but this time we want to go to the last one because there is a new limit. We no longer have 1001 rows as a limit. It's 591. I want that number to be known so I can use that in a for next loop and do my split full names work. I'm going to go over there and I'm going to dim last row, and last row is going to be equal to the active cell. Remember, active cell is the cell I'm positioned on. So in the active cell dot row, and so that number, the row number, which is 591, is going to be the value that's going to be set there. So let's test this. Goes to A1, goes to the bottom, gets the row value into that variable. And now what we need to do is go back. No, we're going to go to range A2. And we want to do for I equals 1 to last row. To last row. Next I. What we're going to do, actually not 1, but 2. And we're going to, for range, our Excel sheet has columns B and C. So I probably want to start with column C because I'm going to end up replacing the value in B. But C, getting the last name depends on B first. So we probably want to do B first, right? So for range, sorry, C, range C, for range and I, which is right now 2, and there's going to be 3 and 4 and last, etc. Dot value, I want to set the value of the range C2, C3, C4, etc. all the way down to 500 and something. I'm going to make it equal to, we have the function. We have function get last name, right? So I'm going to use get last name. And this is a function and it needs to be passed a value. What value does that need to be passed? It needs to be passed B and the current row. So we're going to do range B. Now let's see how this works. Really want to test this because I'm not very familiar with using the for I next, but we can always arrange that. We can always test it. So let's click the play button. Remember, you got to be inside the sub you mean to execute. So we're going to do this. Okay, it's going to go back to A2. Sanders, Jordan, Vo, Barnes, Bailey. Look at them. Look at them. Look at this. Look at this. Boom, 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 boom. All of them. All of them being replaced. So I'm going to remove the toggle and it's going to go all the way down. And let's see if even the last one, yeah, it did it perfectly. It's perfect. What else could you want? Okay, but that's not the only one thing we wanted to do. So we're going to repeat this exercise. I'm just going to delete all of this and I'm going to include here another statement where now that we have get last name set on column C, now we can change B. Now this is something that's going to be quite revealing. So the Excel formulas, you don't lose reference. You're working with active values set in memory at some specific moment. So if we do B and I dot value equals get first name, and we pass the same cell. Actually, this is not going to go into a cycling or anything like that. Look, this is what I mean. So we have a cell which, depending on the value of itself, we want to set a new value. What happens is that first the formula takes precedence. So first we get a value and then we execute this and then we set the value to this new value that has been created. So you're not going to run into some kind of problem. Look, let's just execute this. Split full names. Sanders, Luna, Jordan, Penelope. And it goes on. and we remove the breakpoints, and we got all of our data here. Yes, this is exactly what we needed. So how cool is this? We've just used a couple of loop flow control statements, the for next, and we use the do until, and we're probably be gonna using a few more because we still gotta determine the tax retention and the actual monthly salary thing, and then we need to do a VLOOKUP against another Excel book. So let's pause right here. Good morning, everyone. It's Sunday morning now, and we're going to continue doing our thing. We're going to continue to automate this process, and we're just a few steps away. We're just a few steps. So let's continue. All right, so here we are back with our Excel file, and so far we have managed to create a macro that automatically deletes columns that have no use, which deletes rows for non-US employees or US employees who are termed that are no longer in the company. And also we separated the first and last name. Next thing we should do is calculate the monthly salary because in our hypothetical scenario we have a payroll that runs monthly. You don't see that very often nowadays, but that's how we just created it. I know that in a real world this would be probably a little different. By the way, I'm looking here at some subs which I don't want to use by themselves. When I created the functions, the split last name or get tax bracket, for example, point 24. When I created these functions are available for use, and the macros, all of them, all the routines, the subs are available here. If I didn't want them to show or I didn't want the functions to show, I need to change the code and declare them as private. So when I declare a function as private or routine method as private, it no longer shows in the list of macros. You can no longer use it, but you can use it inside your code base. So for example, if sub format payroll data remains public and this is private, sub format payroll data can still call split full names, but split full names will not show in the list of macros. Let's see how that works. So I'm going to remove the split full names. Not remove it, sorry, I'm going to declare it private. Remove unwanted rows, I'm going to make it private as well. And I go back, macros, view macros, you only see format payroll data. And let's see, the tax bracket, can I make that private? Get tax, you see, it no longer shows get tax bracket, it still shows get first name, get last name, and things like that. So actually, I'm going to keep everything except the subs public. In the end, I'm going to decide whether I should keep some things private or public. For now, only these subs, which we already completed, are going to remain there. So we're back with the final CSV. Remember that we need the monthly subtotal, total tax, and net payment. So I think I'm going to create yet another subroutine or routine to create these three columns based on these ones we have already. So let's get to code. We need to probably get rid of the country. No longer need that. Let's start programming this routine. And I'm going to call this routine sub compute payment data. That's it. That's a good name. I do want to remove column H. So I'm going to put the removing column H here for a moment. I'm going to do just copy this same code I had before. Oh, sorry, this is an insert. No, we want to delete. Okay. So I know that I want a deletion, so I just need to copy this and say select selection.delete and go from there. And maybe even the I, H to the I, because the exit date is no longer needed. Okay, so next would be play this code. Yeah, all good. I'm gonna comment this for now. I would actually like this to be executed at this point of the main routine. So I'm gonna paste it there. And then I'm going to probably insert from G. So once more, I'm going to insert here. Why do I want to insert from G? Because I want to copy the format of money format that we have there. That's the only reason really why I want to do an insert. I could just continue to work in one of these columns. So here we are. I take this code, I put it here, but instead of that, I'm going to go from column G, then execute this. There it is. And we want that to happen twice. So at least for now, I'm just going to execute it again, and then I'm going to copy the code. Well, 3 times actually, because we want to retain the annual salary here until we no longer need it. So here it goes, 3 times. And if I type 1, 2, 3, I type a number here, I still get the same formats, right? So it's all good. These are the exact formats that I need in my Excel sheet. So we did this 3 times. So I'm going to put it here. And then put this over here. I really don't need to comment this. And so we have compute payment data. By the way, in this code, I never called split full name. So let me fix this. After remove unwanted rows, we want to call split full names. So we do our first cleansing, we call remove unwanted rows, we call split full names, then we do some more cleansing, and now we're going to do compute payment data. So in compute payment data, the same principles that we applied before, where we need to understand what is a limit, and we still need all of that. And in these columns, we're going to go from probably from top to bottom and say, hey, just give me the value, give me the value, give me the value, insert a value into each one of these cells, going on a row by row basis. So we need to know our limit. We have a code snippet to do that. I can just copy our range a1.select and selection.end excel down dot select. That's going to be my first step. I'm going to select cell A1 and I'm going to click to the bottom with using like the control arrow key down, which is equivalent to this. And then from the active cell, I'm going to determine what is the last row. So I'm going to go dim last row equals to active cell, my current cell, dot row number. So I have the row and it's all good. And I'm going to do exactly the same that I did for split full names. For I equals 2, because we're starting the second row. The first row has the headers. For I equals 2 to the last row, there's going to be a code block, and I'm going to increment I as an index. So the formulas that I need to apply, or values that I need to set, would be on columns G, H, and I. And according to the CSV, which is the model we're following, we first need the monthly subtotal, the tax, and the payment. So we need the tax bracket, but the tax bracket, we're not gonna paste it anywhere. We don't really need to paste that information. That can be just used on the run to compute the monthly subtotal. So the monthly subtotal would be the annual salary divided by 12 plus the bonus. Yeah, so it's the monthly salary divided by 12 plus that monthly salary multiplied by the bonus. The bonus information is on column J. Okay, so I'm going to start with monthly subtotal G2. So my code is going to be range G concatenated with an I dot value is going to be equal to range F. We're in column F, that's where the annual salary is. F and I dot value. So I'm going to extract the value property from the cell F2, F3, F4, and this is going to be divided by 12 plus I want that same value to be multiplied by the bonus. So that's going to be the value of column J2, 3, 4. So I'm going to put range j and I dot value. So that's a bonus. This is the monthly salary. This is the monthly salary times the bonus. Actually, there's something to understand about the order of operations. Every time you have operations where you have addition or subtraction, first everything else gets resolved, and then this addition or subtraction happens. There's more to learn on the order of the operators. I'm not going to go into much details, but this is sound. It works. But I'm actually thinking that I need to reserve this value because I need to use it again. So I'm actually, instead of changing the G cell, I'm just going to create this monthly, just going to call it monthly subtotal. So now we're going to have a variable called monthly subtotal, which is equal to whatever the monthly salary times the bonus should be. That's the monthly subtotal. Now we need to determine the tax bracket. So if we need to determine the tax bracket, we need to understand what would be the total through the year, because in our payroll policy, in our hypothetical scenario, we actually deduct as much as we project the person is going to make on the year. So what we need is to determine the tax bracket, and for that we have a function equals get tax bracket, and I need to put the annual income and I need to put the year. For right now, I'm just going to put 2023 for the year, but the annual income would be range f and I dot value plus, remember, if I have a comma, first all of this gets resolved and then it gets passed to the function. So I just really need to do range f and I dot value plus um, range j and I dot value times range f and I dot value. So the bonus plus the salary or the annual income, or range yeah. So the bonus rate times the salary plus the salary, and for the year 2023. Now I'm passing year 2023 to the function by default, and I'm hard coding that, but it's not always going to be 2023, right? And we're going to continue to program this function. Again, this is all hypothetical. We're going to continue to program this function to get the tax brackets for the year 2024, 2025, and so on. We still need to pass the year. I'm probably resourcing a lot to the saying that this is a hypothetical example, but what we can do is to assume that this is going to be computed every time during the year. So as long as we're during the year 2023, we are computing for the 2023 tax bracket. So we can take the system date. So something we can do here is, remember that we have the date constant. Well, the date constant will give back the date, but we have the year function which takes the year value out of a date. Remember that those slides we saw a while ago? Okay, so this is what I'm doing. I'm taking the current date in the system and I'm passing that to the year function so that the year can be withdrawn from the date, then placed into the get tax bracket function. So we have our tax bracket, or I believe we have our tax bracket. We have to test this. So we have this monthly subtotal. And there's something about this monthly subtotal that is bothering me. The fact that we have everything divided by 12 at any point. It makes no difference to multiply by the range and then divide by 12. So actually we can factorize this. We can actually go with a yearly subtotal because we can factorize the division by 12. We're talking a little arithmetics here, but it's okay. We can have the yearly subtotal and then we can compute something called monthly subtotal and just do yearly subtotal divided by 12. And that's it. You're good to go. And then you have the tax bracket. And the tax bracket, what I'm doing is I'm doing the yearly subtotal. So might as well take this, remove this, which represents the yearly subtotal, and that's it. I have my tax bracket, I have my monthly subtotal, I have my yearly subtotal. Now, I don't care about the tax amount to pay for the yearly. I care about that amount for the monthly. So from the current paycheck, I'm going to assume that you're going to make that yearly income and I'm going to deduct that much. And then on the tax return, you're going to be happier, you're going to be miserable because you owe money, but at least you got your most of the retention work done. So I'm going to do now what the monthly subtotal, the tax amount on the monthly subtotal. So tax on monthly equals monthly subtotal times the tax bracket. And then I'm going to create one last variable, which is going to be the net payment, which equals the monthly subtotal minus the tax on monthly. The values I want is the monthly subtotal, is the tax on monthly, and the net payment, because that's what I have in my CSV. So now that I have these amounts for each one of the rows, I'm going to go and paste that value there. So I'm going to say range g and I dot value equals, so what should go here? The monthly subtotal, monthly subtotal, monthly subtotal. Range next is total tax, and on H, tax on monthly. And then range GHI equals net payment. All right. It may not be the most efficient piece of code you'll ever see, but it works. As long as it does the work and it's not insanely inefficient, you're good, at least for Excel automation. If you go into other aspects of programming, if you go into other areas of programming, efficiency is all that matters. But here's like, okay, maybe I can afford to do an extra step here. It doesn't matter very much. Don't feel much pressure when you're starting to program on doing things perfectly, but do always try to be better than yesterday. Just that. That's my only advice. You're getting started, do it as you can, get better by the day. All right. So we're going to test this. Range AI will determine what is the limit. It's 591. So from number 2, let me scroll up because this is not actually updated. We calculate the yearly subtotal, the monthly subtotal, the tax bracket, the tax on the monthly, the net payment, and something's not right here. Oh, I hard-coded 1 here. Huh, okay. Little mistake, not a problem. I'm gonna start again. Let's select, calculate the amounts. Not bad. And so the amounts are being populated in each one of their respective cells. Okay, I think we're safe. I think we can run it till the end. So I'm going to remove the breakpoints and bang, we got our payments. Now remember that in the last video we talked about the calibration of items to enable automation. So we talking about McDonald's, and we're talking about frozen patties with the right amount of fat, with the right amount of meat, and which with the right temperature to be placed into an automatic press, griddle press, or something like that, and you get a perfect burger. So in this case, what we need to define is if I'm going to work with many Excel files in my macro or in my program, whatever program, I need to know where these files are going to be located at. And this is kind of the work of calibrating. So every time I run this macro, I know that I'm going to have this file in this folder. At some point during the macro, it's going to open that file, and that file is going to have a name that is already defined, and that's how it's going to work. That's how you're going to calibrate the different elements so that they fit right into the automation process. That's what we were discussing. So, okay, next is we're going to start working with a secondary Excel file to bring some data and probably finish this. Let's go there. All right, so next step in automating our payroll example, we need to bring the routing number and the account numbers. And that's basically the last step. The rest is going to be a little cleanup, but we need to bring the routing number and account number. But remember that comes from a different file. So at one point, I need to make sure that I have the bank accounts file in another folder, that the bank accounts file is a stable, that it has the same name of sheet. Also, I gotta make sure that my base file, which is the employees data file, always has the same sheet name and always has the same columns. That's part of the calibration process that's necessary in order to automate things. So I know that all of the time I'm gonna put the bank accounts file in the same folder as the employees data. So that means that the home path is always going to be the same. So this is the current state of our file. So I'm going to the Visual Basic for Applications editor, and I'm going to create, guess what, another sub, another routine. Yeah, this one's going to be sub obtain and account numbers. That's going to be the end of the sub. Okay, and we're going to face something similar to the path relativity here. So we're going to open another workbook, right? So I'm going to go, again, this is part of the API of Visual Basic for Applications. Workbooks.open, I can just assume that we're going to be in the same parent, in the same home path. So I can just go bank accounts.xlsx, and that's going to open it. But what's really tricky here is, well, if I have an API which says active cell, what is the active cell? The one in bank accounts, or is it the one in my last folder? Well, basically, if you open a workbook, the first sheet of that workbook is the one that's going to be active, and the active cell is going to belong to the workbook that you opened. So how do you change? You got to switch back in order to work, bring some data and switch back to the other workbook and so on. So what you can do in this case is workbooks dot, and your original workbook is always going to be index number one. So you can do, it's not taking my number one here, one dot activate, and then I'm going to switch to workbooks 2 dot activate. You can also reference the workbooks by the name you used to open them, but the one that was open first is always going to be number one. So you're going to have a collection of workbooks here. So let's try this. Workbooks.open, opened bank accounts.xlsx. And then we want to go back to workbook 1. We're back to workbook 1. We want to go back to workbook 2. We go back to workbook 2. No, that was a payroll company. Okay, I had the CSV open, so that was assumed to be workbook number 2. So I'm going to close that. I'm going to start this exercise again. Sorry about that. Quick fix. Nobody gets hurt. Open bank accounts. That's now workbook 2. Should be workbook 2. Hopefully. I switched to 1. I switched to 2. Great. Okay. As long as you don't have a third workbook or something like that open, you're not going to have any problems. But I had the CSV open, so. But you can also change sheets with this. Okay. So I'm going to close the bank accounts again. I have sheet 1 and I have sheet 2 here. So let's say that I wanted to switch not only to workbooks 1 and activate that, but workbooks 1 dot sheets, and I could say sheet 2, or I can use the name of the sheet and say activate. Gonna run this. That opened bank accounts. We go back to sheet 2 in workbook 1, and then we want to go back to workbook 2. Now, you can make it baby steps as well. You can first activate the workbook. Yeah, we can first activate the workbook, and because we're now active in the workbook, we can move to sheets 2. That's also possible. So you can go straight workbooks 1 dot sheets dot activate, or you can do workbook 1 dot activate and then sheets dot activate. These are both. So I'm going to close the bank accounts. Okay, that opened it. Went back to 1. Just move to the other sheet. Play. Okay, we change sheets. We activate workbooks 2. Good, good. So this is working well. Now we're going to focus on the algorithm we need to build, or the routine we need to program to obtain the routing number and the account number. Now, you probably guessed that already. We're going to use this value, the EEID, like employee ID or something like that. That's probably what it means. We're going to use this EID number as the link between the routing number and the account number. And to do that, we're going to go into more loops. Yes, loops, more and more loops. We can think of, for each one of these, go here and find it, and then bring the routing number, and then bring the account number. So how would that look? Maybe I could as well just be preliminary and say I'm going to I'm going to make this inefficient, but in the end, I'm going to transform the code and make it more efficient or something like that. So, okay, we know that the bank account is going to be open. I know that I'm going to be my workbook 1, sheet 1 is going to be active. And I once again have the full employee ID here. I can just do the same trick we've been doing. Select range A1, go to the bottom and tell me how many rows there are. And we're going to do some nested loops. That's going to be really cool. I need to know the limits always for my workbooks2.activate. Is the name of the sheet in bank account sheet 1? Yes, it is. Okay. I also, after I open bank accounts.xls, I want to do this exact same thing. Now, since bank accounts only has sheet 1, then I don't need to worry about changing from sheet to sheet. I could, but I don't need to. I'm not going to say go to sheet 1. I'm just going to activate workbooks 2. So I would open bank accounts. That would become the active workbook. Then I'm going to go to the range 1, and I'm going to deem BA last row. BA last row. And I'm going to say that BA last row is equal to the active cell dot row. So I got the last row in the bank accounts. Now I activate workbook 1, sheet 1, and I do the exact same. I go to range A1, I go to the bottom, I'm going to name last row, make it the active cell dot row. But this time I'm going to call it M as in employees. Employees last row, bank accounts last row. Next thing I'm going to do is I'm going to create a for next loop for I equals to 2 I'm going to probably deem EEID. I'm going to make it equal to range A and I, which is I is the range from number 2 to the last employee last row. So I'm going to get the value. So this is going to be the value, the EEID. What's wrong? Oh yeah, I cannot do this in Visual Basic for applications. It's a little old. So typically you can do that in Visual Basic.net or Visual Basic 6, or I don't know if there was a 7. I don't think there was a 7. I think the last one was 6. So I have a value to search for. Next thing to do is workbooks 2 dot activate, and I only have one sheet. Now if I want to play it safe, okay, you can say sheets and say sheet one dot activate. Okay, let's better be safe than sorry. Let's go ahead and use it. And now there's going to be another. I'm going to have a nested loop. I'm going to go for j equals to bank accounts last row next j. I'm going to say, okay, if EEID equals range A and J dot value, then we're going to have a code block. We're going to do the end if. So we're going to bring the account number. So J is the numeration for the rows in the bank account files, whereas I is the index of the rows in the employee file. So we're iterating on the employee last row. For each one of those rows, we start iterating from the first row in the bank accounts to find the employee ID. If EEID equals range A and J value, then we want to set column D. We want to set range D and I dot value equals to, we got to go back. Remember that we activated workbooks 2. Sorry. So workbooks 1 dot sheets 1 dot range di dot value equals range. We activated workbook 2, right? So I can just use range. I have to go relative here because I'm no longer in workbook 1. I activated workbook 2. Range J, A, B. B would be the column in bank accounts. And J dot value. So the value of D column, I want to set it to the B column in workbook 2. And then workbooks 1 dot sheets 1 dot range E I, its value, I want it to be set to range C and J, to the value in range C dot J. So we iterate through each one of the rows here, and when we get to the new row, we start iterating on the bank accounts. And in the end, so if we activated workbooks 2, I probably want to go back to workbooks 1. Dot, maybe it's not the most efficient thing, but rather than efficient, I first want to do it right, and then I want to make it efficient. Dot activate. Maybe there's some overhead, but let's see how this would work. I'm going to close the bank accounts. Okay, all we have is employee sample data. And I'm going to use my friends the breakpoints. Oh, by the way, if this happens, I want to break. I don't know if that's an accepted keyword. I can look it up later. It's going to take some time. Okay, let's just run this. Bank accounts open, range A1, go back to workbooks 1, give me the last point. Now let's start rolling. Oh, I'm a little scared. Okay, let's go. Seems like we're finding stuff, right? So what if I get a little more confident and say I don't need these breakpoints anymore? Apparently it's doing its thing. It's filling them out. It's horribly inefficient, but hey, it's doing the work. So we can expect this flipping to go for 500 and something times, and we're going to get our bank account numbers and all of that. I just got to think about a more efficient way to do this. Probably if we stop doing the flipping, the activating, this can be a lot better. So let me try that. Okay, so here's what I did. The bank accounts, to prove that this actually works, I just sorted things and I created some chaos here, and you don't have the employee IDs perfectly lined up, perfectly ordered like it was. So I just put them in some kind of disorder. Now for the code, I stopped the flipping switching between workbooks, and I simply said we're gonna activate workbook one, and from then this is gonna be our active workbook. So any reference to the other workbook, you're going to have to use the full path. You're going to say, hey, for workbooks 2, sheets, sheet 1, range this, do that. And it's okay. You can always remain in the same workbook and use the full reference to the other one. So again, we just set ourselves in the first workbook, the employee data, and then in the beginning we open bank accounts. So that was the active workbook, but we switch back right after we get the last row. And then we do our first for loop, and then the nested for loop, which depends on the bank accounts, and we check if the employee ID from the current range has an equivalent in second workbook. Then the current workbook value, set it to the second workbook sheet 1 range. The current value in the current workbook, set it to workbook 2, and so we move. And then if this situation is found, if we find the employee ID and we bring the values, then we exit this. We don't want it to run all the way 1,000 times or 1,001 times. And that's how it is. We're still disregarding the possibility of a value not being found. We're going to do that later. So we're now going to exit. Going to remove these comments. Going to remove these comments, remove this. And in the end, we close the workbook. So let's close bank account. I thought I had saved already. Okay, nothing seems wrong. Things are going to be a lot more visible now. I'm just going to run it like that. Okay, so they get filled out. It says not responding, but that's kind of normal whenever you do all these searches. Okay, it finished. How can we be sure it's finished? Well, we don't have the play button disabled. If it was disabled, it means it's still running. So it ran well. And apparently the second workbook got closed. So that's also positive. So let's do a little data, let's say sampling. Let's do a little quality check. Alt DFF, you get filters. Same here. Alt DFF. I'm going to pick anyone randomly. Brooklyn Salazar. Gonna open my bank accounts. And I'm gonna say, hey, give me this. So Brooklyn Salazar, routing number 74901-833, perfect. 9716949, perfect. I think checking 2 would do it. E00415, routing number 15262-392, perfect. 90977-361, perfect. So that means that these numbers were found and everything worked out perfectly. So finally, we're going to do the last steps because we already have a reliable way to bring the routing number and the account number, but we still got a few extra columns. We still need to convert this to a CSV. Now, the easiest way to do this, because we don't have any limitations where we need to calculate anything, would be to just record yet another macro. So I'm going to do just that. I'm going to say record macro, macro 6, no problem. And I'm going to remove the bonus. I'm going to remove the annual salary. Now I got to name the columns as per the file. So let me put a stop to this macro. Open our sample CSV file. And I'm going to start yet another one. Record macro 7, why not? We need to change the first column to external ID. First name, last name, routing number, account number, monthly subtotal, total tax net payment. And with this, I'm gonna first save this, or not. Maybe I'll just skip this part of saving. Actually, I'm gonna save this as CSV UTF. It's gonna say that it's gonna lose properties. That's okay. So I save this as a CSV, and I can stop recording. And let's see, macro 6, macro 7. Macro 6, I just deleted some columns. Macro 7, I renamed. And then notice, this is just amazing. In Visual Basic for Applications, you can even save a workbook as something different and make it a CSV. It says file format. There's even a code for that. So you have no problems saving stuff. So what I'm going to do is I'm going to wrap up the code. Essentially, I'm going to take those macros. I'm going to make some other macros private. For example, this point, compute payment data. I want to make it private, but I should use this here. Compute payment data. Then obtain routing and account numbers. That should have been private. And then we have the code that we developed for macro 6 and macro 7. You can just delete here the ends of and the macro and all of that and just, stick this together. I can even get rid of macro 6. I can put this code at the bottom of my main macro, my main routine. But I do want to create a different name for this. I know that I'm always going to be working on this folder path, but I actually want to name this as the other CSV file using that pattern, the payroll underscore company, and then year, month, and date. So I want to calculate the name, dim file name equals payroll underscore company. This would be a hypothetical company name. And then we're going to use the ampersand concatenation and use the year of the current date. Remember that is a constant. And then we want to, this is going to be a little more complicated. We want the month of the date. However, sometimes you can have a single digit or two digits. So what we're going to do is we're going to apply a parenthesis here to separate this operation from the rest. And I'm going to say put a 0 always. Okay, so if it's January, February, March, 1, 2, 3, months 1, 2, and 3, I'm going to put a 0 here. If it's October, November, December, I'm going to get probably a 1, 0, 1, 1, 1, 2. And I'm going to get 0, 1, 0, 0, 1, 1, 0, 1, 2. But I'm always going to use a left operation here. So after this concatenation, what I want to do is to bring only two characters. Oh, sorry, not from the left, from the right. Day of month. I'm not sure I can get the day of month. I gotta remember that. Let me pause this for a second and look it up. I can't quite remember how to bring the day of the month. Let me check it out. Okay, so not too bad. We have the day function, and it says here it's safe to use. So I'm gonna trust it. Why not? Just and day of the day of the current date. And yeah, we need to stuff it a 0 in case we have a single digit date. So we want a 0 here, concatenated with the date, and then from the right, we want the last two characters always. And that will do it. And then in addition to this, we need to concatenate and say .csv. And this is going to be the file name. This is the full file name. So whenever we put this here, we can remove this section, do another concatenation, and put the file name that we just generated over there. So it's the moment of true. I'm gonna revert the file, and then I'm gonna run this and see how that goes. All right, so let's see how this goes. We have the employee sample data has been equipped with a macro. I could run the macro right from the Visual Basic editor, or I can use the list of macros here and just say run. I think this is what I'm going to do. Remember that previously in our hypothetical example, manually it took 20 something minutes to run. Normally a payroll takes way more time than that, and there are far more details than those that we were able to record. But this should take just a few seconds. Let's see. So it says it can't find the bank accounts.xlsx. I don't know why is that happening if I obviously have in here bank accounts xlsx. But maybe, just maybe, if I do the full path. All right, one more time. I just decided to use the full path of the bank accounts file. So let me try to run this again. See if that does it. Huh. Okay. Well, apparently it did like to use the full path, and it seems to be working. I think so. And what do we got here? Let's take a look. External ID, first name, last name, routing number, account number, monthly, subtotal, total tax, net payment in a few seconds after just clicking a button. And if I close this, I guess I'll hit save. That's already there. Okay. No, don't save. I'm just gonna reopen this. We have payroll company 2023 1210. We open this, and this is the exact format that we need to upload to the bank. Okay, so we automated this, and now you know the formula to automate quite a few different file types. Wasn't that amazing? That just a click of a button and then you get payroll ready and you can have anything else ready. Now, I couldn't expose every single feature in the language, but I'm hoping that I exposed enough to cover most cases, at least enough coding material for us to be able to automate most of the cases, like opening a secondary workbook, switching between workbooks, and things like that. Fact is that there are more features in the Visual Basic for Applications languages, but the main purpose is also to get a glimpse of what it is to do instructional programming, and there are a lot of languages for that. So now I'm going to cover a few last items, for example errors, catching errors, and the infamous goto. Regardless of a language, the code execution could fall into errors where it will just stop the execution of the program, for example a division by zero error or trying to open a file which doesn't exist. Like it happened to us, the file did exist, but I really don't know why it was working before and then it stopped working. But there's also errors you may want to raise voluntarily and stop the execution intentionally. Even moreover, you may want to program some code in case something fails. So in case of an error, you'd like to pass the flow to another code block, like a mitigation, like an error control. In those cases, there are different languages offer different solutions, mainly try-catch blocks, because Visual Basic for Applications is not as robust as some other general programming languages. What you can do here is to use a go-to marker. Now, the go-to marker is a practice that is very discouraged nowadays. They don't want us to use this because it produces a spaghetti code. More on that later in a future video. But basically, go to marker, you divert the code to a block that is under the marker. So normally you would have like a routine, a sub in Visual Basic for Applications, and a point where you say on error, go to marker, and then you continue with your code. Now, if your code finishes successfully, you reach the exit sub statement, which you must type there, else you're going to continue with the next section of the code. But then you can exit the sub healthily, and if the code block runs into some kind of error, then it will go to the marker and start executing the next code block until the end of the method. Then you may want to throw an error yourself, like why not? You can find a situation where, hey, I don't want this to run anymore, or I want to raise the error inside an if block and then go to the error, go to the marker. Maybe you want to do that, but it's probably better to make solid code that runs all of the time, I think. But still, you can do this. You can voluntarily throw an error with error.raise, and then you have to put this constant from Visual Basic for Applications VB object error, and then put an error number that you can identify, then a title that never appears, and then a description of the error which shows here in the message, and that just stops if you don't do any on error marker. An honorable mention in flow control elements, switch case and select case. I couldn't find a situation where I would like to show this, but it's a flow control statement that is widely used. It's available in every single language. I couldn't find a case scenario here where you actually look for specific discrete conditions. What happens is that the if, you can do very complicated conditions, greater than, less than, and, or, and all of that, whereas in the select case statement you just have a bunch of possible values. For example, in here you said select case number, the number has been set, so case 1 to 5. So if it's a 1, a 2, or 3, or 4, or a 5, then cases 6, 7, 8, case 9 to 10, not really necessary because there's only two possible values there, and case else. So it's a discrete form of the if statement. On our next chapter, we're going to go into more instructional programming addendums. We're going to give more structure to what we just saw. We're not going to do a large, long example like we did. We're going to basically just talk, set the theory on the table. This is what instructional programming has to offer to you. We're going to complete whatever gaps we had in this example, because as complete as it seems, it's not really super complete, and also the code is a little inefficient. So we're going to talk a little about code efficiency. We're going to see other automation scenarios at the office, what other things we would like to automate that we could, and we're going to talk a little bit about tech stacks to keep automating, because Visual Basic for Applications is not the end of the story. There are many other languages we can use and many other things we can leverage to do our automation. So congratulations, you're on track for automation. You've learned something very valuable today. Actually, pretty much every single one of the things we saw, you can check it out on Google, you can check it out on Bing, you can check it out on whatever search engine you prefer. There's a very large section at learn.microsoft.com, which is actually the official documentation of the Visual Basic for Applications API. And I wish you luck in your automation and see you on the next chapter.